Hello all. In this lecture we will see about pandas, and in pandas we will see about first there are two data structures in pandas, series and data frames, and we will see about series. So pandas is a major tool that is used for data manipulation, mainly for data cleaning and data analysis. So if you have some tabular data structure, if you want to store some tabular data like Excel sheet or CSV files, then you can use this pandas data structures, and you can use functions methods in pandas to retrieve some rows or columns or some values from tables. So Pandas it contains data structures and data manipulation tools which are designed to make data cleaning and analysis fast and easy in Python. So it is for mainly for data analysis and data cleaning purposes. So it works with NumPy, SciPy, and all other statistical tools also. Visualizations, we have already seen Matplotlib and all. So this Pandas will also work with those libraries. So Pandas adopts significant parts of NumPy style of array-based computing. So we have seen already NumPy array. So Pandas adopts all the NumPy array-based computing, and that here also data processing can be done without for loops, like we have seen in NumPy. And it is also designed for working with tabular or heterogeneous data. So if you consider NumPy, it is only for homogeneous data. Because only one set of column values will be there. But in the case of pandas, we can work with tabular or heterogeneous data. If there are multiple types of data also, we can work with pandas. So there are mainly two data structures in pandas. First one is series and second is data frame. So we will study about series in this lecture. So series is actually a one-dimensional array-like object. It's like array containing a sequence of values. It is similar to NumPy types. And here we have an array of data labels. That is, we call it as index. So it is a one-dimensional array-like object containing a sequence of values. But it has an index also. All the values will be indexed using some indexing mechanism. So we'll see an example to do this thing. So first of all, in order to do this, I am creating an alias. I'll be using pandas as PD. Now from pandas, I have to import from pandas. I have to import series. Since I am going for series, it is S capital series and data frame. So these are the two data structures that we are importing from pandas. Now if I want to create a series, so if I want to create a series, so it is a one-dimensional array-like object. So it is a one-dimensional thing. So I'll show a simple example to create a series. Series equal to, I am giving some name for that, SCR is a name for that, PD dot, let me zoom it a little bit so that it's visible to you. Okay. Okay. So PD dot series of, now you can give a list of values. So you can give any values like 2, 3, 5, -8, like this. You can give any values. Now if you can check what is there in this. You can see that this is a set of values 2, 3, 5, -8. You can see there is an indexing also. Since we have not provided any indexing, it will take default indexing that will start with 0 and up to n minus 1. It will be from n minus 1. So left column represents indexing, and these are the actual values. So if you want, you can check for the values by using values variable. Oh, sorry, values. You can use the values attribute. So if you check this, you can see it is an array. So 2, 3, 5, -8. Similarly, if you want to check the index also, you can use the index attribute. So you can use the index attributes. So this is the index. It starts from 0 and stops at 4 by a step size of 1. Okay, so this is how pandas works. So this is how, sorry, series. So we can declare a series like this. So the series is declared like this, and you will get a set of two columns. First one uh, denotes the index, and the second one is the actual value. Okay. Now if I want to create an index of my own type, so here there is default index. Now if I want to create some other series, I want to have my own index, then it is also possible for pd dot series. Now I have to give some values. Okay, now I have to give some values. I'll give the same values 2, 3, 5, and -8. Let it be the same values. Now if I want to create my own index, then I can use the index attribute index equal to, and I have to give a list of values. So you can create any values. Let it be a d comma e comma a comma f. You can create your own indexing. Now if you check series 2, you can see that index has been changed. Now I have used my own indexing. So I have used my own indexing, and you can check for the indexing also. Index attributes ser2 dot index. You can see all the indexes. So this is the index is DEAF, and the data type is object. So these are all objects indexing. Now you can use labels in the index if you want to select some single values or set of values. So if you want to select a particular value, you can use labels in the index. If you want to select this one 5, then what you have to do is you can use this thing like this ser2. Now you can use the index labels in the index. So if I want this 5 value, I can use quotes. In quotes I can give simply like this, so it will return 5. And if you want to have a set of values, it is also possible. So if I want to have a set of values from this, so what I have to do is I am giving d, then I will take another value a. So we have a, then I will take also f from it. So let me check it. So so what is wrong in it? D comma a comma f. So the problem here is I have to give it as a list. Okay, sorry, I have to give it as a list. So I have to give it as a list, then only it will work. Okay, sorry, let me clear this all. So what you have to give is I have to give it as a list. Now you can give d comma, I'll give e comma f. So you'll get like this d23. So if you want to get a single value or a set of values, you can use labels in the index to select a set value or a set of values. So in this way you can access the values from it. Now like in NumPy also, it is possible to do filtering, like, or you can do scalar multiplication, or all those mathematical functions can be applied like in NumPy. So if I want to apply some boolean functions, like to select all values greater than let it be 2, so it will return all the values which are greater than 2, that is 3 and 5 will be returned. Similarly, if you want to do some arithmetic operations, it is also possible as into 4. So if you give it is scalar multiplication, all the values will be multiplied by 4. And also you can use numpy also. So here for that you have to import that numpy, import numpy as np. Now you can use the same exponential of, so you'll get those values like this. It will take the exponential of each of the values. You can get so all these things are possible in this X. Or also you can check whether a particular thing is there in it or not using the in operator. So if we want to check whether B is there in SCR2, so if we check, it is false. Now if you check for A in SCR2, so it will return true. So this is also possible. You can check using in operator. Now if I want to create a series from a dictionary, it is possible to create a series from a dictionary. So we have already seen a dictionary. So if I want to create a series from a dictionary, so I'll give some values. I'll create a dictionary first. So inside this I'll create some names. Okay, Jacob. This is the key value, and I'm giving some salary value. Then I'll give another name, Tom, and the key value and the value salary, let it be 32,000. Then Mira, and the key value, it is 46,000, let it be anything. Then I'll give one more value, Zaira. Okay, so I've given some values. Now this is a dictionary. So I have created a dictionary. So if you check, this is a dictionary here. So this is a dictionary. This is the key value and this is the value. So if I want to create a series from this dictionary, it is possible. So I am creating a third series 2 equal to, I can use the same series method, series. Now inside this, what I have to give is, I have to give the series dictionary. I have to give the dictionary. So dictionary is data. Now if I do this and if I check this, you can see this. Now sorry, it is SCR2. Now if you check, we have created a series from it. So we have created a series. So it will be in the same order like this. It will be in the same order as so we have created the dictionary. Now if I want to change the order of the values or of the rows, I can easily change it for that. So it will be in the same order as I have given in the dictionary. If I want to change the order, then it is also possible. So I am creating, if I want to change the order, I am creating an index separately. So I will create this index separately. Now I am giving some other names also. So Arun. So actually Arun is not there in this name. So I am simply giving Arun, and I am giving another name, Abhay. Then I'm giving some names from the value Tom. So I am specifying these are the indexes. Okay, Mira and Sarah. So I have created some index. Now if I want to create a series in this order, in the order of this index. So if I want to create a series in this order, so what I have to do is I can use pd dot series, sorry, pd.series of, I'm creating for the same thing. I'm using the same dictionary here, dictionary, comma. Here I am giving an index. So index should be in this order. So index is this way. So what it does is, now if you check series 4, you can find that Arun and Abhay. So if you see this dictionary, Arun and Abhay is not there in the dictionary. So it will be mentioned as NAN. That is not a number will be mentioned here. So Arun and Abhay will have 9 values. Then next is Tom. Tom will have some value. Meera, Sarah will be there. So it has avoided the resting, that is Jacob has been avoided from the list. Additionally, we have included this Arun and Abhay. So it will create a series according to this index. So it will create a series according to this index, and if there the value is not present in the dictionary, then it will be substituted with this NaN values. Okay, and in this way you can use methods to check whether it is null or not, to check whether there are NaN values in this. If you have a long list and if you want to check whether there are NaN values in it, you can simply use the is null method, and you have to give the object. So there are two null values, NaN values are there, the rest are false. Or you can use the reverse also. Pd dot not null method is there, not null method. You can check whether those there are how many trues and how many false are there. Then we have instance methods also. There are instance method you can use is null. So this also gives the same value. Is null, is not null, everything is there. So it is already there. Now another thing you have to check, another useful series feature for many applications is that it automatically aligns by index label while we do arithmetic operations. So if you are doing some arithmetic operations, it will align with the indexing. So if I will see the series 3, so if you check series 3, it is of the same values, and we will check series 4. So series 4 we have the foreign values. So if you are trying to add series 2 plus series 4, so if you add series 2 plus series 4, sorry, it is not series 2, sorry, series 3 plus series 4. So if you try to add series 3 plus series 4, you can see that Jacob in series 3 there is Jacob, but there is no Jacob in it, so it will be NaN value. Here there is Tom in series 3, and in series 4 also there is Tom. So it will add 32,000 plus 32,000, you will get 64,000. Then Abhay, it is NaN here, and there is no value inside Abhay for this. So it will be NaN. Arun also NaN. Then Meera. So Meera, it is 46,999, and here also we have 46,999. So it will be both added together, we will get the value. So when we perform this arithmetic operations, the series has a feature that it automatically aligns by index label. So it automatically aligns by index label. So it will check for the index labeling, and it will automatically aligns with it. Okay, so that is a feature of align. Then we have name. If we want to name a series, so if I want to name a series, and also if I want to name the index also, it is also possible. So series 4 dot name, I want to give some name for the whole table, or the whole table if it is possible. So employee, I will name it as employee. And if I want to give the name for that indexing, it is also possible. Same series name for dot name dot index equal to name, sorry, index dot index dot name. So it is index dot name. So I have given a name for the whole table and a name for the indexing. Now if you check SCR4, you can see that we have an index name here, and the name of the whole table is employee. So we have given a name to the indexing and also for the name of this thing. Now, a series index can be altered. If I want to change the series value indexing, I can alter it. For that, I will take the first thing. So, first thing it is index by 0, 1, 2, 3. If I want to change the index of this thing, it is also possible. If I want to change the index, then you can use ser.index equal to, you can give a list of values like a comma, you can give any values, c comma, I am changing the index, so all the four indexes will be changed. Now if I check ser, it will be all the indexes from 0, 1, 2, 3 has been changed to a, c, d, e. So that's all about indexing. So that's all about series. So you have to learn all these things. So series, how to create a series and how to create a series from a dictionary, and it aligns with this thing. So in many operations we have to align, maybe we have to add two tables and all. So for that you can simply use this plus operator. It will align with the indexing, and if we want to give the name to the whole table, it is also possible. So we have to if we want to change the index names, it is also possible. So that's all about series. Thank you.